Assalamualaikum. For this Pbl, we have been asked to solve the numerical integral problem. For this problem, it was given a tabulated data of mass movement at reactor over time, which given the formula of m is equal to integral of 2c dt with the limit of t2 and t1. Through the given data, both trapezoidal and Simpson 3/8 rule was selected as the solution. Firstly, the trapezoidal rule was selected due to its formula h/2 times function of 0 plus function of 1, which can be repeated until the third function, because since the data number of interval is 1, for example f0 plus f1, f1 and f2, f2 and f3, and because the interval of each data is equals to 10 until the which they are increased evenly until the function of 3. So for the first step, we must find h. For trapezoidal, h is equals to b minus a, where the second data will be minus to the first data. The second data, which will be the 10 minus 0, will be equals to 10. Then from h, we could evaluate the value of m1 and m2 and m3, because referring to the table, the function of 3 and from function of 0 until the function of 3 are having the same interval, so the value of h is the same. So we could use the trapezoidal rule to figure out the value of m1, m2 and m3 by using the formula of h/2 times function of 0 plus function of 1, while the m2 we're using the value of the formula of h/2 times function of 2 plus function of 1, while for the m3 is equal to h/2 times function of 3 plus function of 2. Then, to calculate the remaining value of the data, which is the from function 3 to function 7, we need to use the composite trapezoidal rule, because the from function of 3 until function of 7 are having the increment of 5 rather than 10. So the value of h will be changed, so we need to find the value of h. For the trapezoidal rule, h is equals to b minus a over n, where the n is the number interval of from function of 3 until function of 7, where the n will be 1, 2, 3 and 4. So the second data, the final data will be minus with the first data over 4. So 50 minus 30 over number of interval, which is 4, will be 5. So from h, we use the composite trapezoidal rule formula, where the formula given is h/2 times with the function of 3 plus 2 function of 4 plus 2 function of 5 plus 2 function of 6 plus function of 7. So we could calculate M4 is equals to h over 2 times function of 3 plus 2 times function of 4 plus 2 function of 5 plus 2 function of 6 plus function of 7. So when we get the value of M4, we could find the solution of the problem by sum up all the value of M, which is M1, M2, M3 and M4. Then we could get the final answer for the trapezoidal rule. Next, for the trapezoidal rule for MATLAB, there are few steps to find the solution on MATLAB by using the trapezoidal rule. For the first step, all the value in the table need to be put in the bracket with its declaration. For example, for the time data, we must put all the data from function of 0 until the function of 7 in the bracket, and we declare it with a t. And for Q, it's equal, we still use the same step until all the data had been tabulated. And for the second step, for the multiplication, there will be a dot and star for the multiplication in MATLAB to avoid the error. So the integration of the M, where the formula given M equals to integration of QC, we need to multiply the data of Q and C. So that's why QC is equals to Q dot star C. Then for the third step, in MATLAB, we use the trapezoidal numerical integration function, where the MATLAB are having the trapezoidal function. So we could calculate the trapezoidal rule by using the trapezoidal function in the MATLAB. So the MATLAB will calculate all the data and give you the answer. Next, the Simpson 3/8 rule was selected because due to the formula of h of Simpson 3/8 rule, the h is equals to b minus a over 3, where 3 must the 3 is the number of data interval, which is the data are having the same interval of 10 from function of 0 until function of 3. The number of data interval is 1, 2 and 3. So we could use the Simpson 3/8 rule for this problem. So for the first step, we must find h, where h is equals to b minus a over 3, where b will become the last data, which is function of 3, the 30, minus this, the data of function 0, which is 0. So 30 minus 0 over 3. So the h will having the value of 10. Next, from H, we could find the value of M1 by using the fixed formula of Simpson 3/8 rule, which is given 3 over H over 8 times function of 0 plus function of 3 function of 1 plus 3 function of 2 plus function of 3. So M1 times 3 times H, which is 10 over 8 times function of 0 times 3 function of 1 plus 3 function of 2 plus function of 3. So we could get the value of M1 from the fixed formula of Simpson 3/8 rule. Then to calculate the remaining value of the data, which is from the data of function of 3 until function of 7, we need to use the composite Simpson rule. Since the interval of data function of 3 until function of 7 are having the interval of the increment of 5. So the first step, we need to find value of H. We're given the formula of H equals to B minus A over N, where the N is the number of interval from function of 3 to function of 7. From 3 to 7 are having the number of N by 1, 2, 3 and 4. So they're having the N equals to 4, so we could find H. So H equals to the final data of F7 minus F3 over 4. So 50 minus 30 over 4. So we could find the value of H is equals to 5. So from H, we could calculate the remaining value of the data by using the formula of M is equals to H over 3 times function of 3 plus 4 times function of 4 plus 2 function of 5 plus 4 function of 6 plus function of 7. So to use all the data from function of 3 at the function of 7, to find the value of M2. So equals to 5 over 3 times function of 3 plus 4 function of 4 plus 2 function of 5 plus 4 function of 6 plus function of 7. So we could calculate the value of M2. And finally, we could find the solution for the problem by sum up the value of M1 and the M2, the fixed value of the Simpson rule, Simpson 3/8 rule, and the composite formula for Simpson 3/8 rule. So M equals to M1 plus M2 equals to 9623.5 M. Next, for the Simpson 3/8 rule of MATLAB, as a trapezoid rule, we must, for the first step, we must put all the data in the table in the bracket with its declaration for the multiplication function later on in the MATLAB.